Hello everyone, I Dr. D.M. Pawar presenting here a topic on slope morphology. In the study of geomorphology, lithosphere, rock, land and soil are essential components. Basically, geography deals with the study of atmosphere, hydrosphere, lithosphere and biosphere. So, three are non-living sphere, whereas biosphere is a living sphere. Lithosphere studied the land component which mostly included in the study of geomorphology. Geomorphology is scientific study of landform, and at the micro and macro level we study different landform, their formation, uneven topography of the earth surface. Peak point of the world is Mount Everest, that is 8,848 meter from mean sea level, whereas lowest portion of the world is Mariana Trench. And in the geomorphology, relief and slope is one of the most important phenomena or component. In the process geomorphology, slope morphology point is included. Geomorphology is divided into different branches: tectonic, climatic, applied, theoretical, and regional. What is slope? Slope is nothing but it is inclination of land. When the land surface of the earth is that it is largely made up by the different slopes. Surface of the earth is combination of slope varies angle from 0 degree, that is nothing but horizontal flat land, and to 90 degree, that is vertical. Here this image and this terrain shows what slope characteristics. Here this is slope angle which represent gradient also, and this red line shows slope length, whereas this green line shows slope width. When we consider topography, that time the uneven topography shows the high level peak, whereas gentle slope land, steep slope land, and their description is given. According to angle, the description is given. When the angle is 0 plane and when the angle is more greater than 55, it is nothing but it is escarpment or there. In slope morphology, when we consider any portion of the land, that time when we go to the micro level study, we can see different slope segment of the earth. And when we draw a cross profile or longitudinal profile, we can find out different slope profile elements and their segments. Here, on the basis of digital elevation model, different cross profile have been made, and according to this cross profile the slope segment have been found. Now what is elements? Elements will be convex or concave in the profile, which would be divided into four elements: waxing slope, it is convex of hill crust; free face, it is vertical or very steep rock face; constant slope, it is maintain constant angle of the rest; and varying slope, it is below the constant slope which is formed by the fine material. Here this ideal profile is shown and it is the ground reality. Uh, Always slope segment is not necessary to follow the pattern. The 9-unit slope model which is developed by Dalrymple in 1968 here is represented from hilltop to the river segment. He has divided 9 slope units containing from value, sample, etc. This is slope development. How slope develop? In the world, when we see different landform, their slope pattern, different types of hills, their different shape. On the basis of this, there are several theories which gives you prediction of how slope is developed. Basically, slope formation can be divided into three types: tectonic slope, erosional slope, and depositional slopes. These are some factors which mostly affect on slope development. That is nothing but the climate factor which mostly affect gravity, changes in the base level, that is upliftment, presence lines of weakness on a slope, degree of saturation, vegetation, etc. The slope development evaluation model, which is developed by slope decline William Morris Davis, slope replacement Peng, and slope retreat by King, is well-known model in the world. Here, in the first model, that is slope decline, the description given by American geographer William Morris Davis. This model is also known as model of cycle erosion. In this model, steepest slope of beginning of process is a progressively decreasing angle in a time to give a convex upper slope and concave lower slope. Slope will continue to decline and develop and evolve from youthful stage, mature stage, old stage, and finally it become a low relief peneplain. Peneplain is the last stage in the slope decline theory, but in reality we cannot found peneplain. This theory is known as slope decline. Here the detailed description is given. First, the landform is uplifted, then in the youthful stage rugged topography has been shaped, steeper slope. In the mature slope, erosion is increased, slope becomes slowly down, and in the old stage slope becomes slowly down, the valley become wider, and finally it get the peneplain in old stage. On the basis of this, the cycle of erosion theory is developed by William Morris Davis. In the youthful stage, initial drain poorly developed, constant drainage initially, low drainage density, swamp and lake, insecant drainage being to develop. Whereas in mature stage, this is second stage of cycle of erosion, basin relief reduced, stream become gradient, stream gradient reduced, valley widening accelerated, V-shaped valley were formed, floodplain were developed. And the final stage of cycle of erosion is old stage to peneplain, where gentle sloping plain just above base level, very gradual transition between flood plain and valley walls. Real example are hard to find why upliftment is peneplain. Slope replacement. The maximum angle decrease through replacement from below by gentle slope causing the greater part of the profile become occupied by the convexity. The convexity may be either smooth curved or segment. Slope replacement developed by Peng. Evidence from arcs and ants, the slope maximum angle decreases in the greater lower slope. Waxing slope will be replaced by free phase replaced by constant slope will be replaced by waning slope. Slope replacement. Slope parallel retreat is one of the theory. Slope parallel retreat. This is the example of slope parallel retreat. There are actual no universal pattern of slope evolution. Slope are related to rock types, vegetation, various types. Thank you.